Hi guys, my name is Jamil and today we will discuss about the last topic of the second chapter of the biochemistry, and it's about DNA repair. It's too much easy and very important for the exams. It's very important for the exams that what is DNA repair? DNA repair means that when a DNA can be damaged. When our DNA is damaged, then we have to repair the DNA damage. Otherwise, it can cause mutations, and mutations can cause cancer. First, we must know that what is DNA repair. You know that structure of DNA can be damaged. Structure of DNA can be damaged either by the chemicals or radiations when they will act on the DNA, and DNA can be damaged, or maybe the incorrect base pairs mean that complementary strands of the DNA mean that what is complementary? You know that at Girls College, adenine will form the bond with thymine, guanine with cytosine. Mean that these will form bond with each other, so it will be correct base pair. But this base pair may be incorrect. So incorrect base pair maybe lead towards the DNA damage. But this DNA damage must be repaired. This DNA damage must be repaired, and this DNA damage is repaired by some enzymes, some specific enzymes, or we can say that some DNA repair mechanisms. If this DNA repair is not happened, then it causes some diseases. It causes some diseases. So maybe cancer, mutations. So today our main topic is that what damage happens, how this damage happens, and what DNA repair mechanisms are involved to set that damage for DNA repair, or if that DNA repair doesn't happen, then what kind of diseases maybe happen. This is our today's lecture. And first we are going to see that damage, what is the cause of the damage, which enzymes recognize that damage, and which enzymes cause the repair of DNA. There are three damages which are mostly seen in DNA. The first one is the thymine damers. First you must know that what are the thymine damers. Thymine damers, you know that thymine always form the bond with adenine. Look at this, thymine will form the bond with adenine. You can see here that thymine forming the bond with adenine, thymine with adenine. This is the normal complementary DNA strand. So it is the thymine, but what is the thymine damers? In thymine damers, the two thymine will not form the bond with adenine. So these are not forming the bond with adenine. They can form covalent bond with each other. Two adjacent, two neighbors thymine can form covalent bonds with each other. It will cause the formation of thymine damers. Mean the thymine damers will form, two thymine will form double bond with each other, and they will not form the bond with adenine, they will form the bond with each other, and will cause the formation of thymine damers. You can see here, cause is the ultraviolet radiations. When ultraviolet radiations will act on the normal DNA, then it will cause the formation of thymine damers. Thymine will form double bond with thymine, it will become the thymine damers. So it was about that. Now this mechanism is the DNA repair mechanism. First was the DNA damage. This is the DNA damage and its cause. The second is the how this DNA damage is recognized and how it is being repaired. I mean that this too includes the DNA repair. No DNA is going to be repaired. The recognition or excision enzymes mean that the enzymes who will recognize this process is the excision endonuclease. So excision endonuclease enzymes will come. So there is a problem. There are the thymine damers. These will come. These will recognize this problem. After recognition, they will come and they will cut these damers. They will cut the phosphodiesterase bonds. So they will cut the phosphodiesterase bond between nucleotides. So these phosphodiesterase bond will be cut down, and they will remove this part. The part where there is a problem, where the thymine damer has been formed, that part will be cut down by the excision endonuclease enzymes, and that part will be removed. When that part will be removed, then the recognition of excision enzymes process has been done, and next process is the repair enzymes. Mean that no, there is a gap, it has been removed, then you can see that here is a gap. Then after that, DNA polymerase will come. DNA polymerase will again come. And what is the function of DNA polymerase? The function of DNA polymerase is the formation of new strand using the DNA template. DNA one strand as a template. They will use these bases and form another template. Now here this has been removed. DNA polymerase will come, and DNA polymerase will, remember that in DNA application, the DNA polymerase will read at the template strand from 3' to 5', and it will form on sensitive strand from 5' to 3'. on the new strand. So it will move from here, it will come here, and he sees that here is a gap. So this DNA polymerase will read this sequence on from 3' to 5', and here is a adenine, then it will add the thymine. So it will add the thymine here. But this has been removed. This has been removed. This is not here at all. So it will read this adenine and form the thymine. It will again read the adenine and form the thymine. So now it will become the normal one. You can see here that polymerase act, then it will use the adenine form the thymine, adenine, thymine. So these bonds will be formed. But you know that there was the removal of that part. So there will produce some nick. Here will also nick. Here will be also nick. What is the function of DNA polymerase? Is synthesizing the new strand. But the function which causes sealing this nick is DNA ligase. Then DNA ligase will come and DNA ligase will join these parts, will form the phosphodiesters bond between these two. The remover part has been removed, but here is another part of nucleotides. So these nucleotides will be bound with each other by phosphodiester with the help of ligase. So ligase will come and they will seal this nick and it will form the normal DNA. So what is the concept behind this? That thymine dimers will form. Thymine can form double bond with each other. It is caused by ultraviolet radiations. Then Excision endonuclease enzyme will come. They will recognize this. They will remove this part by cutting phosphodiesters bonds. Then polymerase will come. Polymerase will use again this sequence and form another nucleotide by normally, and then ligase will come and ligase will seal these nicks which has been produced here. So it will be sealed and no DNA has been repaired. This was the first damage. And the second damage is mismatch base, and this thymine damage happens in G1 phase. You know that interphase at 3 phase, G1 phase, S phase and G2 phase, and this thymine damage happens during G1 phase of interphase. Second damage is mismatched base or mismatched base. Mismatched base. You know that in simply case you can see here that at Girls College, adenine will form the bond with thymine, guanine will form the bond with cytosine. This is the normal complementary scene. But you know that there may be some problem after the DNA has been synthesized. So here must be the thymine, but now here not with the thymine. Here may be the guanine, and here is a problem. So here is a problem. So what will happen when there is a problem? Then this problem is caused by the DNA replication errors. You know that during DNA replication, DNA polymerase also have the proofreading activity. Mean that if there is a problem, then we have studied about it in the previous lecture, that if there is a problem in the DNA replication mismatch behavior, the DNA polymerase will jump back, then it will cut the mismatched pair, and again it will form the new bonds. So it is about the previous topic. So DNA polymerase has exonuclease activity, but still there may be some problems. DNA polymerase has this activity, exonuclease activity, but still remain these problems. But these problems are very, very rare. Maybe one of the 500 million, maybe very rare problems. This may be occur because DNA polymerase has already this proofreading activity, but this occurs. This maybe happens too. But in G2 phase, after this DNA has been replicated. So now here is a problem after the replication. Then here must be the guanine, but it's a thymine, but here is a guanine. So let's suppose that it's normal, not this. No, please forget about this thymine dimers. Forget about these thymine dimers. Forget about these thymine dimers. Now let's suppose that here must be the thymine and here must be thymine, but here is a guanine. So now in humans there are two genes, human MSH2 and human MLH1. These are two genes. These two genes will recognize this error. These two genes will recognize this error, and they will encode some enzymes, and their enzymes will come. That enzymes will come here, and they will cause the recognition of this part, and they will remove this part. And you know that here is a G. They will come and they will remove all of this part. This part will be removed. This part will be removed. Then the process, the function of the DNA polymerase and DNA ligase will stop. Then again, DNA polymerase will come. Then it will read the sequence, and it will because it will come and again it will correct the mistake. Here will adenine, and instead of guanine, this part has been removed, and it will add again thymine normally, and nick will produce that is sealed by the ligase. So what is the mechanism? That mismatch maybe happen. Even DNA polymerase has proofreading activity, but there may be problem, but very rare. That problem is solved by these two genes will encode the proteins, enzymes. These enzymes will come, these enzymes will see that there is a mismatch, they will remove this part will be removed. Then polymerase will come, they will again use the sequence of the template strand, and they will form the again normal, and the ligase will come and they will seal this nick. So it was about the second damage of the DNA. The third damage of the DNA is about cytosine demyelination. Cytosine demyelination. Remember that what is cytosine demyelination? Remember in the first chapter we discussed that. Let's suppose that this is the cytosine single-stranded cytosine. This is a single-stranded cytosine, and you know that in a cytosine there is a amine group on the top, and there will the demyelination will happen of the cytosine, and it will be changed into uracil. Mean that when this will be missing, demyelination mean that amine group will be missing. When this will be demyelination, then it will be formed. What will be formed? Uracil will be formed. So here he is saying that cytosine demyelination. When cytosine demyelination will form, then cytosine will be changed into uracil. And it is caused by the spontaneous maybe something happen, or maybe because of the heat. When heat will come, this process maybe happen, and it will happen in G1 phase also. Like that, thymine damage, it will also happen in G1 phase. So now here is a uracil formation, but you know that in DNA, this is a DNA, and in DNA we just need thymine, we don't need uracil. So we need thymine. So here must be thymine, here must not be uracil. So what is the purpose of uracil here? So we have to remove this uracil. So now let's suppose that here was a guanine, and here was a guanine, and here must be the cytosine, but instead of cytosine here is a uracil. But we have to remove this uracil because here we need cytosine, not uracil. Then this uracil then two enzymes, that uracil glycosylase and AP endonuclease will come. First this enzyme will come, uracil glycosylase, and he sees that here must be C, but here is a U who is forming bond with the G. So this will come and it will break this bond, uracil will go on in. This enzyme will recognize and break this bond, and the function of the second enzyme will start. That what is that? AP endonuclease. AP stands for the apyrimidinic. Pyrimidinic. So this enzyme apyrimidinic endonuclease will come, and he will see that there is a problem that is cutted by the uracil glycosylase. It has broken this bond. Then this enzyme will come, AP endonuclease will come, and he will remove this part. This part will be removed, and he will remove this part out of here. So this part will be removed. Then again DNA polymerase will come, he will read the sequence again, and he will form the normal. I mean that will go on and will form the cytosine, and he will again the formation of nick because of removal of that part, and this nick will be sealed by the ligase. So ligase will come. So what is the concept here? That cytosine demyelinase will happen during G1 phase, where the cytosine will be changed into uracil, but we need no need of uracil, we need cytosine here. So this may be spontaneous. Uracil glycosylase will come, and first it will break the bond of uracil with guanine, and then second enzyme AP endonuclease, apyrimidinic endonuclease will come, and he will remove this part will be removed. Then polymerase will come, and polymerase will again read the sequence and again will form the normal one, new strand. Then here will be produced the nick because of the removal of this one. So here is a nick, here is a nick. This nick means the cut point. This cut point will be sealed by the ligase enzyme. So ligase enzyme, and they come and they will cut it and they will seal it. So now DNA has been repaired. So these were three basic damage in the CLA: their causes, their recognition, and which enzymes repair the mechanism. So it was. Now in this we will see the cell cycle, that in cell cycle how these damages happen, in which cell cycle, and how are they being recognized, how are they being repaired, and if repair doesn't happen, that which kind of disease may be happen. So now please let's start. In this slide, you know that there is a thymine damers. Thymine damers mean that thymine will form double bond with thymine, covalent bond. They will not form with adenine, they will form bond with each other. So thymine damers will form. So this thymine dimer will form because of the ultraviolet radiations, and this thymine dimer is repaired by the Excision endonuclease, and DNA polymerase and DNA ligase. These enzymes will come, they will control this mechanism. So this will be repaired. And the second that happens in G1 phase, that was the cytosine demyelination. Mean that cytosine will be changed into uracil. So we have to change this process. This process will be repaired by the uracil glycosylase, AP endonuclease, DNA polymerase and DNA ligase, which we have studied in the previous slide, that this will be repaired. So this both has been repaired. When this repair, then the next mechanism is no cell has to enter from G1 phase to S phase. No cell has to enter from G1 phase to S phase. So no, for this entrance from G1 phase to S phase, they need a permit, and that permit is given by the two genes controlling entry to S phase. That genes named as the tumor suppressor genes. Because if there is a mutations, then these genes will come and they will suppress these tumors. Therefore, these are called tumor suppressor genes. These are two genes which control this entry. That is the RB and P53. RB stands for the retinoblastoma. RB stands for the retinoblastoma. This is a gene. This is another gene, P53. What is? Let's suppose that everything is okay. This repair has been done. Then it will become door into S phase. They will allow the entry. But if there is a problem is here. Mean that there is no correction. Correction has not been done. Here this correction not has been done because of some reasons. If not correction, then this rhabdoblastoma sees that there is a problem. And you know that from to enter the cell from G1 phase to S phase, you need growth factors. Growth factors like insulin will act, and then G1 phase they enter into S phase. No, there is a problem. Then this retinoblastoma will go and they will block that growth factors which cause the entry of G1 phase and S phase. When that growth factors will be blocked, then growth factors will not come. Growth factors will not come, then G1 phase will not come into S phase. So they will block the process. And the second gene is P53. That's too much important. That's too much important gene here. P53 is just like a security. He is sitting here and he is checking everything. And he sees that there is a cell is going to enter into S phase. When cell will come, then he will see the cell. That there is everything okay. Cytosine demyelination is there. No, it's okay. Thymine dimerase repair is okay. Then everything is okay. He will allow into that. Let's go. If there is some problem, he sees that there is some mutations, then he will sit in front of that no, there is no entry. He will block that entry. He will block the cell from G1 phase to S phase, and he will say the cell that go back and correct your mistakes. So cell will go back and again he will correct these mistakes. If these mistakes are not being corrected again and again, problems happening, that cell is coming again and P53 is sitting there, go back. Again and again he is sending him back, but this problem mistakes are not being corrected. Then this P53 will start its second mechanism, that is apoptosis. P53 will send signal to cell that undergo apoptosis. He will order that shoot this cell. He is not listening to me that please shoot this cell. First that he will say that please go back and correct your mistakes. If mistakes are not being corrected, then he will order that please shoot this cell, and this cell will undergo apoptosis and it will be finished. So in this process, these two genes will control their entry. So if there is everything is normal, then these two genes will give the permit, and then G1 phase will come in S phase. Now in S phase there is a normal DNA. This normal DNA will be replicated in S phase. You know that in S phase DNA replication happens. It will be replicated in S phase. After S phase, then it will be entry into G2 phase. When it will be entry into G2 phase, then you say that in G2 phase there may be the mismatched bases. DNA polymerase have proofreading activity, but maybe some mismatched pair. So these mismatched pair are solved by the genes MSH2 and MLH1. So these mismatched pair will be solved, and then cell will enter into the mitotic phase and cell will be divided. Normal mechanism. But there are some problem. What is that problem? That problem is that these enzymes may be missing. These genes and enzymes may be missing. When we talk about the first one damage, that is the thymine damage that happens in G1 phase, this is controlled by Excision endonuclease. So if there is a problem in this enzyme is deficient, defective enzyme, this enzyme is defective, then it will cause the disease that named as the xeroderma pigmentosum. This disease will happen if this enzyme is defective. If this enzyme is defective, this disease will happen. And what is this disease? In this disease, thymine damage will be formed. Mean that thymine will form the double bond with thymine. These thymine damage will remain in the cell. So in the DNA. So these thymines will remain and they will cause the xeroderma pigmentosum. And this xeroderma pigmentosum is an autosomal recessive disorder. This is an autosomal recessive disorder. And what are the clinical features? How it is characterized? It is characterized by that the patient will have extreme sensitivity to sunlight. When sunlight will explore to that patient, then it will give sensitivity to the patient, extreme sensitivity. And second characterized will be that skin freckling. Because of sunlight, it will cause skin freckling. And then next is skin cancer. You know that there is mutation. Because of mutation, it can cause skin cancer. Because of sunlight, also exposure to him. And next is the skin ulceration. Sorry, it's not skin ulceration. It's the corneal ulceration. It's the corneal ulceration. Corneal ulceration is a little ulcer in the eye, in front of eye. So it will cause the little ulceration because there is still mutations. So it will cause the corneal ulceration also. But how we can diagnose it? We can diagnose it by a blood sample. We will take the blood sample and we will check this enzyme in the white blood cells. Blood sample has white blood cells. In white blood cells, we will check this enzyme. If this enzyme is okay, mean that these symptoms may be some because of another disease. But there is an endonuclease enzyme in white blood cells defective. Then we can say that this disease is the xeroderma pigmentosum. It is because of the defective this enzyme, and this enzyme has been defected. So still there is a thymine damage in our DNA, which causes the xeroderma pigmentosum disease. So it was about that if this problem is not solved. And second disease is that named as the HNPCC, or second name is the Lynch syndrome. So what is this? You know that these are two genes which cause this mismatch repair. If these two genes are not working okay, there is a problem in these two genes, then these two genes will not produce the proteins or enzymes which causes the repair of this mismatch mechanism. So proteins will not form because problem is here. Here is a problem, proteins will not form, then this will not be happen. When this will not be happen, then there will be some mismatches. Mean that adenine must be with thiamine, but instead of thiamine, adenine with thiamine with adenine, guanine with cytosine, cytosine with guanine. There will happen the mismatch. Here maybe the guanine, mean that their mismatch will happen, and this mismatch will start. And this mismatch will cause the disease that named as the HNPCC or Lynch syndrome. And now HNPCC stands for the, I am going to written here, that heredity. That stands for the heredity non-polyposis colorectal non-polyposis colorectal cancer. So this HNPCC stands for the heredity non-polyposis colorectal cancer, or we call it Lynch syndrome. In this disease, there will be the mismatch pairs of the nitrogenous bases. So mismatched pair, they will lead towards the mutations, and you know that mutation will cause the cancer. So it can cause the cancer. Lynch syndrome, it can cause the cancer that named as the heredity non-polyposis colorectal cancer. Why it is called heredity? Because it is related to gene, and these genes may be inherited. So if there is a problem, then it can cause this disease. So it was about that. And there is an extra thing, that is the macrosatellites instability. What is that? First, you must know that what is macrosatellites. Macrosatellites is the di, tri or tetranucleotides repeats, especially on non-coding region. Let's suppose that this is a one DNA strand, this is the second DNA strand. You know that these strands are complementary, mean that this adenine will form the bond with thiamine, thiamine with adenine. Mean that you can see that this is the complementary sequence. This complementary sequence may be repeated on another region. Mean that same. So it is repeating, but it is dinucleotide. Mean that two nucleotide. So it is repeating one from here, and second is again come, and again it may be come here. Again come here. So it is repeated again. This is di, but maybe try that here will be the G, C. So here will be the G, C. This may be repeated G, C, tri, and tetra may be repeated. So this is called the macrosatellites normally. But if that cells lacks mismatch repair, means that there may be the mismatch of the nitrogenous base, and this nitrogenous base is not being repaired because of that defect in these genes. When defect in these genes, there will be some mismatches. Mean that T with T here must be the A, but instead of A here will be the G, and then here will be okay, here will be okay, but here is a problem. Then these will be different. These macrosatellites which are repeating again and again, they will be different. Mean that no, they were repeating, but again when this will come, and there will be the G. Mean that when it will come, then here will become the A, T, G, then it will come T, here will be A, but here will be the G, C. So this is mismatched. So this has been mismatched, means that there will be the different macrosatellites. They are not repeating with a sequence. There is a mismatch. So this mismatch, named as the macrosatellites instability, means that this mismatch repair will differ. These macrosatellites will be differ. When they will be differ, they will call the macrosatellites instability. So it was about the DNA repair. DNA, some kinds of damages, and DNA repair. So it was the last topic of the second chapter of the biochemistry. So in next lecture we will start the third topic of the biochemistry. So thank you so much, guys.